So in the previous class, we understood what is HDFS. HDFS is a distributed storage component of Hadoop ecosystem. And we discussed HDFS has name node and data node. Name node is for storing the metadata. Data node is for actual storage of the data. And then in case if the data node failure happens, how to tackle that. We discussed all these things as a part of yesterday's class. Now, if I ask you a question, Shabna, which component does the distributed processing? Which component?
Component means this.
No, component means HDFS is also a component. Parveen, HDFS is used for what, Parveen?
Sir, for distributed storage and
Yeah.
HDFS only.
And which is the component which performs the distributed processing?
The map
HDFS.
reduce.
Yes, yes, it is map reduce. Okay. So we'll just learn little bit about the map reduce. I used to teach 2 to 3 classes about map reduce only, but now it is not required. Okay. I'll just introduce you to the map reduce because as of now, map reduce as such is obsolete. Okay. So then your question may be, why am I teaching MapReduce if it is obsolete? Through MapReduce, you will understand how the distributed processing works. That is the reason I'm just introducing MapReduce for you. Okay? Let us understand what actually is MapReduce. Are you guys able to see my screen? Not yet, right?
No, sir.
No, let me share my screen. Okay. So, are you guys able to see my screen now?
Yes, sir.
Okay. MapReduce is a programming model for distributed processing. The way it works is we have two phases in MapReduce. One is something called mapping phase. Second thing is called reduce phase. There are two phases, mapping phase and reduce phase. If you recollect the story where Parveen cooked a biryani for all of us, if you recollect that, there were two phases. Which are the two phases, guys? Which are the two phases? One is
splitting the.
One is slicing. That was the important processing stage. And the second one is combining that. Right? Combining, getting the same vegetables into one bowl. Isn't it? These are the two phases. In the similar manner, MapReduce also works in two phases. Okay. One is, as I said, map phase and reduce phase. Okay. In the map phase, the individual data is in the map phase. The processing of blocks is done. Processing of the data in the blocks is done. And in the reduce phase, the data with the similar keys are aggregated, are reduced into one output. Okay. So that is how the MapReduce works. Okay. So don't worry. I will take up one story. Okay. To make. Okay. So if I ask you a question, let me ask a question to Malini. Malini, which is your favorite childhood poem or poem? Okay. So how about you? That is wonderful poem. Okay. Poem. Okay. How about you, Parveen? Which is your favorite poem?
Johnny, Johnny, yes, Papa.
Johnny, Johnny, yes, Papa. Okay. Vinith, how about yours? Quickly, Vinith.
Twinkle, twinkle, little star, sir.
Yes. Twinkle, twinkle, little star. Does anybody in the group who has not heard of Twinkle, Twinkle, Little Star? Okay. Anybody in the group? That means everybody has heard. Everybody would have heard about it. Okay. Let us understand the MapReduce through Twinkle, Twinkle, Little Star. Okay. Through Twinkle, Twinkle, Little Star. Okay. Okay. So we have a wonderful poem that is Twinkle, Twinkle, Little Star. How I wonder what you are. Up above the word so high, so and so. Okay. So most of us remember only this paragraph, but there are some other paragraphs like when the blazing sun is gone, when nothing shines upon. Multiple other paragraphs are there. Okay. So don't worry, don't start reading them. But what I want to do is, let us say I want to distribute this file into different systems, the way distributed storage works in big data, and then process those distributed parts by using a MapReduce. That is what I want to do now. Are you guys ready for that? Shall we do that?
Yes, sir.
Okay. Jaipal, are you okay with this? Jaipal, upset with me?
No, sir, no, sir.
You're not upset, right? Basically, you are thinking, okay, sir, you should take my love letter always. What happened? All of a sudden, sir is taking a poem this time. Okay, so we have to move on. That is the reason. Okay. So now, what happens in a distributed storage? Let us say this particular poem is kind of one line is arranged in a table like this. Okay. Then in a distributed storage, what happens in a distributed storage? Big file is divided into the smaller chunks and distributed across the different systems. That is what happens. So now the requirement is what I want to do is I want to know how many times each letter is repeated in this particular poem. Okay? That is what is the requirement. Everybody understood the requirement? Vinith, you understood the requirement? Shabna, you understood the
Yes,
requirement?
sir.
Okay. So in this poem, how many times each letter is repeated? That is what my goal is. Okay. But as somebody said, the data is not at one place in a distributed storage. Okay. So assuming that, are you guys able to see my screen, everybody, now?
Sir.
Yes, sir.
Okay. Assuming that part of the poem is there in 1d6 data node 1, another part is there in this particular data node, another part is there in this particular data node. Okay. That block is also called as a partition. Each partition is given to different processors. Okay. So what happens is, if I want to process it, right? What is the processing? What kind of a processing I have to do here? What is the end goal here? What is the end goal here? What is that we have to do? Anna.
So we have to find how many times that word has
Huh.
appeared.
Let us see, if you were to write a Python program for this, how will you write it? How will you write it? Take a guess. Take a stab at it, Anna. If you were to write a Python program to calculate the number of words in this particular poem, how will you do it?
So using loop. Like,
Okay, very good. Okay. First and foremost thing is, so let us say, if you were to write a Python program to count the number of words, so what will you do is, first thing is, you read a file, right? The second thing is, you parse the file based on wherever the space is there. Okay. Third thing is, after parsing the file, what will you get? What will you get? Based on a space, what will you get? After parsing a file with the space, what will you get, Vinith?
Number of words or number of spaces.
Words. We'll get words. Okay. We will store those words in an array. Right? Then, as Anna was saying, I will iteratively through loop, wherever a word matches another word, then I'll have a counter. Right? That is this is a very simple steps to count the number of words in a file. This is what we do, right? Everybody is on board with this? Very simple, right? Muttiminal, very simple. Malini, simple, right? This is what I do. Okay. Now, anybody has any questions on this? This is what my logic is. Now, coming back here. So, what I want to do is, that logic will be here, sent to each of these systems, because the data is there in these three systems. So what we'll do is, we'll write that Python program and send that program to these three systems. That is what we're sending the computations to the node. Vinith, do you remember? We are sending the computations to the node, right?
Yes, sir.
So each of that code is called as a mapper. Mapper is where that Python code is there. What they'll do? They will process the code in the individual systems. Now, whatever the individual system is, right? This is how the results will look like. Okay. The code, what it is doing is, it is taking a word and providing a count. It is making a pairs out of this. Something called key value pairs. Something called key value pairs. Okay. Are you guys with me? So that Python program, what we have written, which has sent it to the each of these nodes, it is parsing this part, storing this in a array, and creating a key value pairs. Key value pairs. That logic is there in something called mapper. Okay. Then now what happens is, once there are the results for each of the system. There are results in each of the systems. Are you guys with me? Initially, what we did is, we distributed the big poem into these three systems, and since we want to count the number of words, we wrote a Python program which will take the input as a file and parse that and create the key value pairs, and we send that Python program to all these three systems. That Python program took the individual partition as an input and it created the key value pairs. Like that, parallel processing happened. There are key value pairs produced at each system level. So far, so good. Right? Malini, are you with me? Anna?
Yeah.
Is it clear? Is it clear? Okay. So what is happening here? It's a distributed processing is happening here. Distributed processing is happening here because that Python program is processing all the data at the same time. But is this the final result? Malini, is this the final result?
No, they have to count twinkle, twinkle, how many times it has appeared.
Shabna, this is not the final result, right? This is the intermediate result. This is the intermediate result. Okay. Like Shabna, Mutminal, and who else? Muskan. The way they sliced the vegetables, right? In the similar way, these are the intermediate results. So finally, what Parveen did in that story, biryani story, is she took the intermediate results, like vegetables sliced by each one of them, and combined them into final result. The same thing is done by something called reducer. It takes the intermediate results produced by the mappers and then combines the words with the same key as final result. You guys are with me?
Yes, sir.
Right? So this is what happens. The final result will be produced by a reducer. Okay. Final result will be produced by a reducer. Okay. This is why it is called as a MapReduce. This is why it is called as a MapReduce. So MapReduce is a programming model for distributed processing. Okay. It works in two stages: mapper phase and reducer phase. At the mapper phase, the processing happens at a individual data node level, and then those intermediate results are passed to something called reducer. Reducer combines the intermediate results into the final result. This is how the MapReduce works. Any questions here from anyone? Okay. So at a high level, what is happening here is MapReduce, which is a programming model which came very early when the big data, the whole concept of big data came into picture. This was the very early programming model which was excellent, which was used in multiple companies at that point of time for the distributed processing. Okay. The way, if you really see, mapper accepts the input as a key value pair and produces the key value pair, and reducers takes this input as a key value pair and produces the key value pair. So the way MapReduce worked is, any data processing tasks should be expressed in key value pair. That is how the MapReduce works. That is how the MapReduce works. Okay. You guys got it? So MapReduce is the programming model for the distributed processing. This was the one of the first programming model for the distributed processing. Any questions here from anyone? Okay, wonderful then. Now, if there are no questions, I want to cover couple of things. Okay. Are you guys okay if I cover a couple of things?
Yes, sir.
Okay. One very, very important thing is, as I already indicated to all of you, MapReduce itself, I used to cover some 3 to 4 classes, but now I'm kind of limiting myself to cover the MapReduce because MapReduce is no longer used. But I covered MapReduce just to show you how the distributed processing happens. Okay, one of the way distributed processing happens. Okay, now that we understood this, let us understand a couple of more important things. So we are learning so far, if you really see, we learned what is data, what is information, what are the different ways of storing the data and processing the data, and we learned some aspects of the RDBMS, where one of my colleague Nandraj covered the SQL, and then we understood data warehouses for the analytical processing, and we understood there is a MDM, we understood there is a big data, we understood the basics, central theme of the big data, distributed storage and distributed processing, and then we understood HDFS, we understood MapReduce. HDFS is for the distributed storage, MapReduce is for the distributed processing. Where are we learning all these things? Shabna, where are we learning all these things?
So, big data
Why are we learning big data? For what purpose?
for storing the data, large
Why are we
amount of
storing the
data.
data? Why are we storing the data?
We need to handle the
Parveen, why are we storing the data? Why are we discussing all these things? For what purpose?
For the analytical processing.
For the analytical processing. Why do we need to do the analytical processing?
Why means to take some important decisions in the business.
Absolutely. Bingo. Shabna, you got it, right? See, we are learning, we are doing all these things to help, or to aid, or to facilitate. Take business decisions. You got it, Shabnam? You got it? Malini?
yes, sir.
Anna? See, we're doing all these things to help, to aid, to facilitate the business decisions. So, any idea? Malini, can you give me one example of taking a business decision? Example of taking a business decision. Or anybody for that matter. Can somebody tell me what is a business decision? Anybody? Vineet, can you take a stab at it? What is a business decision? Take an example of a business decision.
Yes, sir. Yes, sir. I am
Thinking.
going to elaborate it. Let's suppose I'm a umbrella seller.
Okay.
So I have to sell umbrellas in Delhi. So first I have to collect the data that in Delhi, what are the months in which the rain is going to happen. So
very good.
Then we look back into the data since many years, and then and by analyzing that data, I can find that in July, June, or August, my business will boom.
Very good. One of those things. Okay. Now, when we say business, right? I mean, to simplify further, So business involves couple of things. I mean, I'm oversimplifying it. Okay. So like you have to what are these things? Increase the revenues and decrease the cost. Okay. These are the two important aspects of any business. Right. So you can increase the revenue by selling more. Right. Or increasing the price. Okay. Or having more products. Right. So we can decrease the cost by, how can you decrease the cost? Anna, these days what they're doing is laying off employees, right? Employee cost. Okay. And procuring the raw materials at cheap cost. Right? So, and then improving the efficiency. Are you guys with me? Are you guys with me?
Yes, sir.
Anna, Parveen, Shabna,
Yes.
are you guys with me? Okay. So this is how you, this is how you decrease the cost. This is how you increase. I mean, I'm just taking few examples here. Okay. Now, let us say Amazon. So Anna, if Amazon has to take a decision to increase the price, how will it take the decision, Anna?
To increase the price, sir.
Increase the price of something. Okay. How will it take a decision?
So they will check for like how frequently that item has been bought.
Mm-hmm.
So if it's in more demand, they can take that opportunity to increase the price.
Wonderful. But where does it find which item is bought more? Where will it get that information? Where will it get that?
All that will be stored in a database, sir. So from
Yes. Are you guys able to get where I'm leading to now? Okay. Shabna, Parveen, Vinith, Malini,
Yes, sir.
Mutuminal, are you guys able to get it right?
Yes, sir.
Yes.
So that is why we are doing all these things. Why are we learning all these things is at the end of the day, with whatever we are learning, that will, with that knowledge, we're going to help the organization to take the business decisions, right? So if you see what Hannah said, that data is stored somewhere. Okay. So that is where data engineering comes into picture. The data engineering comes into picture. So when you talk about the data engineering, what happens is, again, I am oversimplifying it so that you guys understand it. Okay. What we do is, as Anna said, the data is in some sources, right? Source can be database, source can be file, source can be some application. Are you guys with me? Are you guys with me? Is it boring or is it interesting?
No, sir, it's interesting.
Right? The data is in some sources. It can be database. Database can be Oracle, MySQL, PostgreSQL, IBM DB2, something. File can be CSV file. It can be JSON file. It can be XML file. Application can be any application. Okay. So the data is in some sources. Okay. By taking the data in some sources, that sources we need to extract that data and store that. Store that in some storage areas. It can be, again, it can be data warehouse, it can be data lake, it can be again a database. Okay, we have to store that. We have to store that. Okay, then we may have to analyze that. Okay, or we may have to process it. Okay, to process it by transforming that data. Okay, once we analyze, once we process that data, basically the processing is the important thing. Okay, then we have to visualize it. We'll visualize it. Okay, through nice graphs. You guys are with me, right? So, as a part of the data engineering, we do these things. We have sources from which we extract the data. We store that in some data stores. We process the data. And we visualize the data. So that by visualizing the data in a nice manner, that will help the management to take the decisions to run their business. Okay, so this is what happens in the data engineering in a very, very simple manner. There is a source, there is a storage layer, there is a processing layer, there is a visualization layer. This is how the data engineering is simplified in a very simple manner. You guys got it? Any questions here? Okay. Now, in order to do this, there are multiple things. Okay. So for extraction also we may need tools. For storing also we may need platforms. For analysis, for the processing also we may need the tools or platforms, right? For visualization also we may need tools or platforms. So this whole thing, there are multiple tools in Hadoop ecosystem to perform each of this. It can be extraction, it can be storage, it can be processing, it can be visualization. Now, what is happening is Microsoft Fabric is bringing all these tools and platforms into one umbrella, one platform. This whole thing of extracting the data, storing the data, processing the data, visualizing the data can be done by Microsoft Fabric. You guys are with me? We did discuss so many aspects lead to this. You guys understood why are we going to learn the Microsoft Fabric now?
Yes, sir.
Makes sense now?
Yes, sir.
Parveen, Anna,
Yes,
Mutumina,
sir.
Yes, sir.
Malini, Shabna, is it
Yes,
clear?
sir.
Because you
Yes,
have to
sir.
understand these basics, right? So now what we will do is, next we will learn something called PySpark. Where am I writing the PySpark?
Analyze and
Processing.
In the processing, right? In the processing. I am writing the PySpark in the processing. So PySpark is another platform used for processing. Okay. So what we will do is, before we venture deep into the Microsoft Fabric, we learn PySpark at a very, very high level. PySpark again is a 40 to 50 classes tool. Okay. So but we don't have so much of time. Okay. Good news is I have recorded the PySpark videos. All of them are uploaded in the YouTube. Okay. So if you just learn PySpark at a high level, definitely we can get into the Microsoft Fabric. So what I will do is from tomorrow, okay, I will take few classes, maybe couple of classes on the PySpark. Then we'll venture into the Microsoft Fabric. Okay. In the Microsoft Fabric, all we'll do is how do you store the data? How do you extract the data? How do you process the data? How do you visualize the data? By building something called pipelines. By building something called pipelines. Okay, we'll discuss about that. Is it clear now? Is it clear now, all of you? Is it clear? Is it making sense?
Yes, sir.
Sir,
Yeah,
I have
please
a
go ahead.
question.
Yeah, please go ahead.
Sir, so both the MapReduce and the PySpark are used for processing the data, right, sir?
Absolutely. Absolutely. You are bingo. You are right. Thank you for that. In India, I'm going to talk about that tomorrow. You are right. MapReduce is also for processing, and PySpark is also processing. Which is the one for storage? Which we learned already?
HDFS.
Yeah, SDFS. It comes here.